Perfect. Good morning, everyone. Good morning, good evening, good afternoon, depending on you are on the world at this moment. My name is Afonso Solac. I'm civil engineer from the Department of Software Development of CYPE. Today we will be talking a little bit more about the new release of CYPE. That is the release or the new version. It's the version 2021. Okay, so during the last 2 days, we have been talking about a little bit about all the new features that we have on this version. On Monday, we have been listing all these new features. Yesterday, we have been talking about CYPE architecture. That is a new software that we have. That is a software to develop 3D models, 3D architectural models. Okay, based on the IFC standard. And today we will be looking at the new features for the new structural solutions that we have on our products. Okay, so now today we have new tools in some softwares that are traditional softwares, and we have also new softwares. Okay, so we have both situations. Just to show you what we have been talking before. On yesterday we have been talking about the architectural modeling with CYPE architecture, okay, and today we will be talking about this part, so this part of calculation, analysis, design of structures. Okay, so just to show you the index that we have today, we will use this structure here. Okay, we'll start with CYPE architecture. I will show you a little tip, kind of workflow that we can adopt. The parting from CYPE architecture, developing the geometry of our structure on CYPE architecture. We will export that to StruBIM CYPE 3D, where we will calculate our structure, and then we will export again and send this information to StruBIM Steel, where we would add the details of our joints, our connections, to generate this file to manufacture this structure, this steel structure, after the project is done. Okay. Once we finish this first part, that's gonna be talking about steel structures, then we will go to reinforced concrete, and we'll show some new features of CYPECAD and StruBIM Shear Walls. Okay, so that's our plan for today. We'll see 5 or 6, maybe 6 apps, 6 softwares, and let's start with that. So here I have the CYPE architecture. So if you came yesterday and see this software, this is the same software we have been talking yesterday. The idea here is just to create a little geometry here. I'll create a new project on our platform on BIMserver.center. Please, if you have any question, just send me a message using the GoToWebinar panel. We can try to answer that probably in the end of the presentation. Okay. I'm just creating here a project, an empty project. So it's gonna be just an example. It's closed, no one can work on that, just me. And let's create this project. We don't need this PowerPoint anymore. And this is the workspace of CYPE architecture. Okay, and I will not explain everything about this software today. If you wanna know more about this software and you couldn't come yesterday, we have recorded this presentation of yesterday, so you can ask me. We can send you the presentation of yesterday. Okay, but here I will just create a kind of geometry here, just to create a sketch of something. It's just to generate geometry, a different geometry. So we can start creating, I don't know, for example, a rectangle. We could say that this rectangle could be, I don't know, maybe I don't know, 20 meters to 12 meters, for example. So our rectangle here. Okay. Then we can, for example, extrude this rectangle. So we have this kind of features here, for example, 12 meters. Okay. Then we could, for example, offset one of the surface. So for example, here we could say that we have this other square, this other rectangle here. with a distance of, I don't know, maybe 2 meters, okay? We can maybe extrude it again, for example, okay? I'm just doing something here, actually the geometry doesn't matter too much. It's just to show some features that we have here and show the flexibility that we have on this software, and show that all these drawings here that we can create on SYPE architecture, we can transform into a structure on SYPE 3D, okay? So we can increase our possibilities of modeling structures if we combine SYPE architecture, that is a free software, with SYPE 3D, okay? We could use a circle and create maybe a new circle here. For example, let's do something, I don't know. Let's use a radius here of, I don't know, 4 meters, or it's too small, like 8 meters. Let's see. No, 8 is too much. 5 meters, for example. Then we can also extrude it again, okay? So just creating a geometry here. And this information now we can send to BIMserver.center using our panel here, this right side panel. This panel we have on all our softwares is the menu that you use to connect with the platform. Okay, you just check. Let me check in here. It's okay. So, but before we send this sketch to SYPE 3D, okay, or StruBIM CYPE 3D, that is the new name of the software. Maybe we can classify the surfaces of this model here in different layers, or maybe in different materials. And then when we import this geometry on StruBIM CYPE 3D, we will have the same materials, and it's going to be easier to associate structural elements to these different materials that we will have on the model. Okay, so to do that, let's say that I'll create two materials here. For example, I'll create a material one that's going to be for example, the horizontal panels or horizontal surfaces. And I'll say that all the horizontal surfaces are, for example, yellow. Okay, yellow and orange, for example. Okay, one face of the surface is going to be yellow, the other one is going to be orange. Okay, and then I'll create another one that's going to be the vertical surfaces. Okay, for example, vertical surfaces. And this one, I'll say that it's going to be, for example, green and I don't know, blue. Okay, so two materials here, and then we can use this button here to assign the material to the structure. So I'll select, for example, first I'll select everything. I'll say that everything is the vertical surfaces. It's going to be everything green. You can see that this surface is blue because it's the other surface of the surface, the other face of the surface. So we can invert that or maintain that. Okay, my convention is going to be all the green faces. They will go. It will be will be above the surface. Okay, it's going to be this surface here, and then we can assign the other material, so the horizontal surfaces, to this surface, for example, this surface, okay, and of course this surface. Then we have two materials here. They are separated between horizontal and vertical surfaces, for example, but we could do much more than that. Okay, it's just a simple example. And I will add some lines here. These lines is because then we'll convert that on a structure. It probably will need some bars to connect this cylinder that we have on the top with this rectangle that we have above. Okay, so I'm just adding some lines that maybe could connect and transform it on a structure after we transform it on a structure. Okay, so is just to have some connection here. Okay, and Actually, with that, we can just export it to BIMserver.center and try to open it on StruBIM Type 3D and take a look on what we have. Okay, so export here. I will say that that's going to be just a volume, for example. It's going to be a volume.ifc, and the exportation is finished. We have a local copy on this folder here, so I'll just copy that. Okay, and then I'll go to StruBIM CYPE 3D. Okay, so this is StruBIM CYPE 3D. From now on, you can download StruBIM CYPE 3D directly from BIMserver.center, as you can do with CYPE architecture. So just going to BIMserver.center, coming here to the store. You can't download. Let's wait until it loads. Here on the new features, you can download CYPE architecture and StruBIM CYPE 3D. Okay. So you can also search here for any other software, or you can choose the different categories that we have here. For example, structural analysis. We have this category of the applications, so you can download StruBIM CYPE 3D from here too. And this is the interface of StruBIM CYPE 3D. It's quite similar to other softwares. I'm connected with my account here, logged in on BIMserver.center. So let's create a new project. I'll say that is empty project. Okay. Here we can set up the materials, the sections, the loads, the reinforced concrete if we have, the foundation, everything about our structure we can set on this menu here. Of course, we can come back and change everything when we need. Okay, so I'll maintain that at this moment. Here we can change the limit states of this the calculation. I'll maintain the same thing. And here we are now on our structural calculation software, CYPE 3D or StruBIM CYPE 3D. Okay, and I'll import that geometry that we generated with CYPE architecture. Okay, when we send the information to BIMserver.center, we can see that if we go to our accounts on BIMserver.center, let me log in here. This information, first, a project was created automatically on BIMserver.center. Okay, this is the first thing that happened. So the project example to 22nd of July. Okay, and inside of this project at this moment, the BIMserver.center synchronizer, that is this app here, sent this information to the cloud. So now if I wanna invite someone to work with me, as you can see, the information is here on the cloud. Okay, if I want to invite someone to work with me, I could invite just using the tools that I have here on the platform. And for example, another person could calculate this structure. I've generated the geometry, but a second person could calculate that with a second software. Okay, so that's one of the good things that we have with BIMserver.center. We don't need to work in the same computer or use just a local file. We have this cloud solution, and you can send to another person. Okay, and if you see here, sorry, I just see that it is in Portuguese here. Just let me change it to English. Let's change that for English here. Now it's better. So now it's in English. Let's go back to our example. I just want to show you that we have a special file here that was generated by CYPE architecture. It's here on the Files tab. And this file, it's available for everyone that is working on this project. So we have this volume here, and if we click, you see that we have some files inside of this folder. Between them, there is a file that is called 3D Sketch. Okay, 3D Sketch. Okay, so this is the file that we'll need to import to CYPE 3D. Okay, and everyone that is connected to this project have a backup on a local folder on each computer. So this local folder, it's always available in this direction here. We just can go there. Actually, you can change this folder if you want. This is the default folder that is created when the softwares are installed, but you can change if you want. Okay, and you can find the same files that you have here on the cloud in this local file. Okay, on this local file. So I'll go there. Have here on here it's my BIM projects folder. This is my user. Actually, I used 2 users in this computer in some moment, so I have 2 folders here, but this is my main user, and here I can see all the projects that I've synchronized before with this computer. Okay, maybe I have much more projects on the cloud that are not synchronized with this computer. We can do that, so it's quite interesting. And as you can see here, the last one is this project that we've just created now, okay, some minutes ago. We can go there. We have here the IFC file and a folder with the same name and other files. Between them, there is this 3D sketch file, okay? The same files that are here on the cloud, okay? The same files that we have here, okay? Okay, let's go back to CYPE 3D and let's import this file. So I'll go here in Tools, then I'll go to this option, Import DXF and DWG files. Let's go there. I'll just navigate on my computer and search for that. So we have here the folder. This is the project, and here is by default is DXF file. We have to change to DWG files. Let's select that and let's click on Open. And here we have the geometry that we created before with CYPE architecture. Okay, here we have 4 layers. 4 layers that are imported. The first one is it's a default layer that is always imported with any DWG file. It's an empty layer, actually, this one that is with the number 0. Okay, then we have 3 layers. Okay, 2 of them, the yellow and green, are exactly the same layers that we created here. Okay, the same materials that we created here, the yellow and green. Okay, the horizontal and vertical surfaces. So now you can understand how it's important to create a good classification of your materials here, because then the reflect of this is going to be the way that you import here on CYPE 3D. Okay, and then we have a third layer that is this one. It's a black one that are just the lines. Okay, we'll see that. Let's wait. We'll see that with more details in a few moments. Okay. First, I'll import, for example, let's see our model here on CYPE architecture, just the green surfaces, okay, just the vertical surfaces. So I'll go there, I'll come here, I'll select here, okay, and I'll import that. And as you can see, we have the surfaces here. We have some references, some axes of reference here. I will deactivate these references. I prefer to work without that, like this, a little bit more clean. And if we go to the 3D view, we can see this first layer, how was imported. We can see that we have some 3D information here. By default, these surfaces were created as reinforced concrete, but we can change at any moment to any other material and change the thickness or any other structural parameter of these shells. Okay, actually we are transforming these surfaces that were just a sketch into shells, into structural shells at this moment. Okay, so that's the process we are doing. And as you can see, we have a lot of triangles here. That was the way these shells were generated by default by the software. But we can join we can come here to the shells and join these surfaces to simplify a little bit these triangles. So I can select everything here, and with the right click, as you can see now, we don't have the triangles. It's exactly a rectangle. Here we have some rectangles, okay? And now we have a much more clean structural model, okay? Let's save that. If we come here to the shells, we can, for example, describe the material. For example, we can select everything and say that's going to be steel, a rolled steel, and we can select one steel. I don't know, I'll select some steel from here. And if you go to the 3D view, we'll see that the material was changed. So now we have steel, okay. And actually here, I prefer this color here. The representation of steel on SYPE 3D is the color red, okay? But we are missing the horizontal surfaces. What I'll do, I'll come back here. I'll import it again. Let's open the DWG file. And now let's import just the yellow layer, okay? The yellow layer, let's import it. I'll import it at the same position defining before in the file. So it's going to be in the same position. And as you can see here, we imported the yellow surfaces. Here on tools, we have a layer management menu. We can, for example, deactivate the green for a while and maintain just the yellow visible, okay? And we have here the same situation. We can, for example, join these loads. Let's just save here these shells. Let's join the shells, selecting everything. Okay, some of them maybe are not coplanar, and there is something that is a peculiar thing, that is that SYPE 3D don't calculate a shell if we have a hole in the shell. If we have a space inside of a shell, so we must divide this surface here in two shells that are connected by a line. So, for example, what I will do, I will join some of the shells and maintain some of them divided. Okay. So, for example, we could select these triangles here and join them. Okay. We are creating a unique shell here, unique shell. Then we can take this, for example. So maybe here I cannot, because it's impossible to create this unique shell. But here probably, yeah, here we can. Here we can. So let's just prepare this shell to calculate. Okay. Here I can't. Okay, no problem. Here it's okay. It's just because we have this empty space on the middle of the shell. So I will work with 3 shells here. Okay, 3 different shells. Then we can create a condition between both of them here on the shells menu to define the internal fixity. So we can say that two shells are, for example, this shell and this shell have a structural fixity that is fixed or pinned or free, okay? And we can simulate this situation. Here we have a little shell that was created, I think. I'm not sure, but it's okay. It's going to be the axis of this little guy here, but I think it's okay for our example. And we have to do the same thing. Here we can come to shells and material, for example, describe material, and we can say that this is a rolled steel, for example, or cold form steel, whatever you want. Okay, don't worry about the materials. We are doing a real example. Let's save that. And if we go back to our layer management, we can activate now the green surfaces and go to the 3D structure. And here we have all the structure that was made by shells. Okay. What we can do, we can just add, for example, here some nodes and define the external fixity of this structure. For example, let's say that we have this condition here, okay? And actually now we can calculate. Let's see if it's possible. Of course, we must add our loads. We have a lot of parameters that we should configure before really calculate that. But with this minimal information, we can calculate something. Of course, it's not a real life structure. It's just an example with a strange geometry. Okay, but yeah, we can calculate that and take some some take a look on how the forces are working on this structure. Let's wait a little bit. I think it's gonna be it's gonna be fast. Let me see if we have some questions while this calculation is running. Mr. Tato, it's asking us for if we can share the yesterday's session. Yeah, in the end of this session, I'll share with you the link of the yesterday's session. Then you can see a little bit more about the CYPE architecture tool. Okay. Actually, I can show you how to download CYPE architecture. Let me show you while this calculation is running. If you just come here to BIMserver.center, you can come here on the store. Okay, it's the same button that we have in the home page, and you can download CYPE architecture for free. Okay, let's wait. Let's wait here. So here you have CYPE architecture, and you just click here. Come on, my internet, I think it's not so good today. It's waiting a little bit. You can download your CYPE architecture directly from here. So the software is available in Catalan, English, French, German, Italian, Portuguese, and Spanish. Okay, so this is CYPE architecture. Okay, let's see what is happening with CYPE 3D. It's calculating yet. Okay, no problem. Let me introduce you the new software while this structure is calculating. We are talking about StruBIM Steel. StruBIM Steel is going to be the next step that we have in this workflow. So we also have this software here on the store. This is a free launch edition of the software, so it's a free tool. In the future, and maybe we'll have some paid modules. But at this moment, the software have a free launch edition. Okay, so let me bring this menu here. So it's this guy here, StruBIM Steel. Okay, you can go to the structural analysis category 2, and you can see the StruBIM Steel maybe in the end because it's a new software. If it's not here, just click on structural analysis, and you can view all the softwares on the red section, the structural section. Okay, and we have here StruBIM Steel. Okay, free launch edition. Okay, you can download it for free, and this is a software that was developed to the creation and maintenance of BIM models for steel detailing. Okay, so we'll generate the details of this structure after calculating on StruBIM CYPE 3D. Okay, so we export this structure from CYPE 3D to BIMserver.center, import again on StruBIM Steel, and then finish our job. Okay, so that's the workflow. Let's see here, 30%. Okay, maybe it was more than I thought before, but I'll show you a new surface that is quite nice. In this while this calculation is running. So just to show you that some things are very interesting. So yes, let's save this guy. Let's open a new surface here. And this surface was created here on CYPE architecture. So you can see we can do a lot of interesting things with this free tool. Okay, and you can imagine that we can export this surface to CYPE 3D too and calculate this. Maybe it could be a roof, or I don't know, something like that. So this is a hyperbolic paraboloid. So you can create a surface that it seems to be curved, but actually it's made just by planes, just by lines. Okay, so you can create that, and you can export to BIMserver.center. Actually, I'll export that too, and then we'll have another example in the end of the presentation. We can see what we can see on CYPE 3D. Okay, let's see here. Our model is calculating yet. I think it's gonna be too much time to see that. let's do something. I will cancel this process, no problem. Then when we change to another program, I will leave this calculation running, and then in the end we can see the results of these shells. Okay. So before we finish with this, I would like to show you something more. I will save this project with a new name, and I'll say that this is my example 2207. These were the shells. Okay, these were the shells. We have it here to finish that after, and let's save as again and say that a new one is going to be to the bars. Okay, why I'm doing that? Because actually we have one layer more that was available on that file that came from CYPE architecture. Okay, so I just delete everything here, and I will import again the same file, the DWG file, 3D sketch, and I use this layer here. Okay, the black layer. Okay, so this black layer imports just the lines. Okay, just the lines that we have here. So it's why I created these lines here connecting the different geometries, the different volumes that we have on the structure. Why? Because if we don't have these lines, imagine that each line will be converted in a bar. Okay, so if we don't have these bars, this cylinder in the top or this rectangle here will be floating in the air, and it will be impossible to calculate this structure. Okay, so actually we can introduce new bars or new nodes or shells directly on the software, but the idea here was to generate a kind of structure on CYPE architecture and just import on CYPE 3D to characterize it and calculate. Okay, just after import, as you see here, we can go to the 3D view. Let's see what we have. We have this kind of situation. So we have generic bars in a red color. It means that we must characterize these bars. So the program doesn't know which kind of material, which kind of section, which kind of structural behavior that this bar must present. So we must add this information to our calculus. And let's do that just coming. Now we will use the bar menu, not the shells menu, bar. And for example, let's describe these bars. Let's select everything, for example, but could be just one of the bars or two of them or a group of them. And we can add a material, a section. So it's going to be I don't know, rolled steel, or maybe wood, or maybe aluminum, or even reinforced concrete. It's just an example. Let's use one profile here from the library. We have a large library here. Actually, you can use a lot of options here of different sections that are included on the software. Okay, you can also edit and add your own dimensions and properties, editing, creating your own sections if you need or if you want. Okay, and let's use this one. I don't know, it's just to put something. Let's put it here and let's see the difference. If we go to the 3D view, now we have this situation. We have the profiles here, the sections here, and actually we can change the materials. The beams are in a green color and the columns are in a red color. Okay, it's just a convention that we have on the software. Now maybe you understand my line here. Okay, it was just to connect the structure. Of course, if we apply some loads here, this structure will not be a good structure. It's just as I said before, an example, fast example. Okay, before we calculate, first we must add some external fixities. So we must connect this structure with the foundation. So now we have here the fixity, and actually now we can connect the structure. I will not calculate that, but I will send this information back to BIMserver.center. Okay, so we have this new menu here. This is exclusively from the 2021 version. I'll link this structure with a project that is on BIMserver.center. I will select the same project that we have been creating before. Okay, the same project that we were working before with CYPE architecture. Let's load our my list of projects that I have on the platform, on my account on the platform, and it was this one, the example 2207. Let's accept. And as you can see, when I accept and I'm connected to this project, I have an IFC available to load here on StruBIM CYPE 3D. So I'll import that. Let's wait. It seems that nothing happens, but if you go to 3D view, you can see that here you can see the geometry that we created on CYPE architecture, and actually it's exactly on the same space, the same place where it should be. Okay, so they actually the same model that is divided in different IFC files. Okay, so we are creating an open BIM project that is composed by different IFC files. Okay, and here actually we can deactivate or activate this information. We could have much more IFC files here, for example, the plumbing facilities or the HVAC systems, or of course, everything about the architectural model. All this information could be here, and we could visualize here using this 3D viewer of CYPE 3D. Okay, let's save that. And now we can export the 3D structure that was generated here on CYPE architecture to the same folder in the cloud. So let's generate a structure.ifc file. Okay, it's exported. And if we come back to CYPE architecture at this moment, you see not in this project, it was the other project. Let's open here. It was, I think this one, it was the new project. Let's open it. So it was this one. We can use this guy here. You can see that this guy is flashing. So it's telling us, hey, watch out, you have a new file. You have a new file that was created on your project. Do you want to import this file to your CYPE architecture project? Yes, I want. I will just update the project. And now I have available the StruBIM CYPE 3D structure. Okay, so it's reversed. I will import it here. Let's open it. It seems that nothing happens, but actually when we double click on one of these views, for example, the 3D views, we have a list of the IFC files that are available on the project, and we can turn it on, just clicking on visible, and now we can see the structure here on CYPE architecture. Okay, for example here. So this is how we work on BIMserver.center, sending and receiving information using this kind of menus with export and update actions. Okay, always using our account, the same account that we have on the platform. Okay, so that was a nice example. I think it's a very nice example that you can, how you can use CYPE architecture to generate geometry, then send to CYPE 3D and calculate there. So here you can create a lot of things, a lot of different forms and geometries. Maybe you can draw your transmission tower or your truss, everything here, and just send to CYPE 3D to calculate. It's gonna be a good workflow. Okay. But that's a new another part. That is we must add the connections, no, the joints in this points. So let's do one more part of our workflow. Now we'll come from this software, so CYPE 3D. We will export as we made it now. So we just exported. Then we can come to a third software, that is StruBIM Steel, and create a new file. So this is the example 2207, but now we are talking about StruBIM Steel, not about StruBIM CYPE 3D. Let's select a project. Let's select the same project. Okay. Let's wait. The list of projects is loading. Let me check something here. It's okay. Okay. And it was this guy here, example 2207. Next. And let's see what we have here. Now we have two files. because it was one file from CYPE architecture and one file from the StruBIM CYPE 3D. Actually, we can import both of them, but we will use just the file from StruBIM CYPE 3D. Okay, let's finish that. And as you can see here, the software found this series of sections. So an IP 330. So this material, we have this material on the library of the software, the StruBIM Steel software. Okay, we can import it from the other model. Okay, here we'll see the list of different profiles, different sections that we have in our structural model. Okay, and we have 128 bars in this model here that were made with that profile. Okay, the profile IP 330. Let's accept. And here we are in StruBIM Steel with the same geometry that was created before. Okay, actually here we can do a lot of things. For example, we can, I don't know, we can delete something, for example, or we can add any other bar. We have here a list of profiles, a list of materials, a list of sections. We can add any other bar here in any position, just create our structure. But in here we are just drawing, we are modeling our structure. We are not calculating anything here. We are just generating a detail of this structure. Okay, so maybe the most interesting part of this software is this joist options that we have here. So we have a list of joists that were created and are included in the library of the software. Okay, these joints are composed by different elements, like here we have some plates, some bolts, okay, some welds and some anchorage. So elements that were first were how can I say, introduced to the library of the program, and then use it to generate some elements. So these elements, now we have here 13 different elements. Okay, so different type of connections between the structural elements or the beams and columns, or I don't know, here we have some different situations. Okay, and all of these connections here, they are we can personalize these connections. We have a lot of parameters that we can change: the numbers of bolts, the size, the if we have or don't have a plate, or we have a lot of options. I'll show you, and you can see that for each connection you have here an information telling us which kind of section that is accepted to this combination. Okay, so to the beam we can use this kind of sections, and to column this kind of sections. But if we change, for example, this one, we have here a purling one, a purling two, and a main bar. Okay, the purling one we can use 3 different type of sections, the purling two also, and the main bar just these kind of sections. Okay, it's the type of section, not the size. The size, it's any size that you have in your library. Okay, but the type, it's the series of the section. Okay, here the same. Here we have a lot of other options to generate this kind of connection. Okay, so let's do something. Let's add, for example, I will do something here. I think it's gonna be nice. Let's delete these guys here. Okay, I don't need these guys here. For example, it's just an example. Okay, and add a connection here to this foundation, for example. Let's use this hinge with pin. Okay, and we can put it here. And now you can see that we opened the menu to personalize this connection. So we can change the material of the base plate. We can change the size of the base plate. So this dimension and this dimension, we can see this code. So this name here and here are this and these guys here. We can see we can change here this other dimension here. That's going to be somewhere here. Maybe it's going to be this. Okay, So here we have a lot of parameters to personalize the element. We can add a button and a button here. You can see here. Okay, let me do again. So this element here is the button end plate, so we can add or not. Okay, we have this option. Then if we have which dimensions it has, the end plate, so this guy here, we can change the formats. We have this situation, or this situation. So we have different situations here. Okay, then the haunches, we can, for example, apply an angle. Let's say that the connection is going to be on 40, oh, yeah, accepted, 45 degrees. Okay, let's come back and keep editing here. Imagine that is not a column, it's a beam that is a slope of a roof, for example, and it's connected to another surface, and it's not it's not a column in a foundation, for example. Could be another kind of element, okay, structural element. Let's leave 90 degrees. Then we can add anchors. For example, here we don't have the anchors. Let's add some anchors. To add the anchors, we can add the number. For example, the first one with some coordinates. Let's say, for example, 200 is too much. Let's say 100 millimeters and 100 millimeters. So we have here one anchor. 100 is not okay because it's here. Let's put 110, for example. 110. I think it's gonna be better. 110. Okay. Well, almost there. 120. Here. I think it's gonna be better. Okay. Then we can do the same for other anchors, just changing here. For example, I don't know, to. It's gonna be. We can change here and add other anchors. Then we can say which kind of anchors we have. So here we can select the size of these anchors. Okay, we can change here some parameters about the connection of these spaces. The type here, just changing the form of these anchors. Okay, so we have a lot of parameters here. The welds here, if we can change the parameters of these welds. Okay, just the format or the size of these welds, we can change these parameters. We have here 3 points. We have this weld here, this, and this. Okay, so we have 3 different points with welds that we can change. And after we finish this configuration, we can export this connection and using this button here. And when we have a new project, we can just import this same configuration to use in another project. So it's quite nice. It's quite interesting. We have a lot of options. Here we can do something that is quite interesting. You can change it for a orthogonal projection here using this option, and then use one of these sections here. And from here we can extract a nice plan, a nice drawing, just exporting using this little button here. So we can print this information and send it to AutoCAD or JPG or any other format. It's going to be a very nice detail to add to your projects. Okay, if I accept, I will see the difference here on the project. Okay, then of course I can for example add. That's a another tool that's quite nice. For example, let's do using this situation here. We have a lot of connections here to create. We can use this button here and select, for example, this column and this beam, and then right click, and the software will say we have 3 options to your connection. You can do something like this, you can do something like this, or you can do something like this. Okay, which one you want to use as your reference? I will use the first one. I will accept, and the software will open just these bars. Okay, just these bars, and now I can add or remove elements. So for example, I can say I can change here some parameters. We can say if the the connection is welded or bolted. Let's say that is, for example, it's bolted. And then we can add, for example, a top launch, for example, here. We could do the same in the other side, but I think it's not okay for this situation. We can add here stiffener at this point, okay? On the column, we can add any other elements. I think it's not okay in this case, okay? So we can personalize the situation again and accept, and now we have here our connection, okay? So this, it was strange, it's not okay. We can, for example, ungroup. Let me see, where is the ungroup here. So we can ungroup this, and then we can delete some elements. Let me see where. I think we can delete, or maybe we must choose another kind of connection. It was not the best connection to this node here, okay? But that's the idea. You can just select 2 bars and see what you can do. Let's see if here we can do something with 3 bars. Actually, it's the first time I'm trying. Here, and here. No, there is no connections are compatible yet with that. But with 2 bars, not this situation. Unfortunately, not the situation, but some of them we can do. So that's the idea of the application. So here we can add this kind of situation, okay? That's StruBIM Steel. Of course, when we finish that, let me see if I can copy something. I would like to. I'll do something. I'll just select here. I will add this guy here, and I will add this guy here. Okay, I'll add some elements here, and I'll save that. And we can also export this information. Let's export. It's going to be the steel structure, for example. Let's put details. Okay, .ifc. Let's export that. It's already exported, and we can now come back to CYPE 3D and update that. Okay, so we can consult here, and we'll have the new StruBIM Steel file. Okay, I will accept that. And on CYPE architecture again. So if we update, it's flashing here. Now we have a new file that is the steel structure. Let's update that. And let's see what we have here. Okay. Unfortunately, with just some minutes that we have here available to show that, we cannot do a real structure with the real elements. But I think you can understand you could understand what we are trying to do here. As you can see, we have now 2 IFCs available on this list. Let's activate the second one. We'll deactivate the first one. And as you can see, we have the elements, the crazy elements that we made here. I'm sorry about my imagination. It's not the best. With more time, for sure, we could do something more interesting. But we can see now here on CYPE architecture also the details that we created on CYPE on StruBIM Steel. Okay. There is another thing that is quite interesting. That is when we generated this IFC using StruBIM Steel. Okay, when we exported here in our local folder, in the same local folder of the project, this subfolder was created, this steel structure. And inside of this folder, we have all these files that are with the extension .nc1. Okay, so these files are used to introduce on those machines that are used to manufacture the structures, okay, to manufacture steel structures. So we have these formats that were generated, and you can send to your manufacturer to cut in the exactly places or to generate the plates that you need with the sizes according to the materials and geometry that was introduced on the software. Okay, so that's quite nice because we departed from a sketch using an architectural software. Then we went to an analysis and design software that was CYPE 3D, and now we can extract the details to manufacture this structure. So we have all the cycle of the project from the start to the end, okay? And all the materials that you add here, they were introduced on those files that were exported, okay? Here we have a report, and we can see the takeoff in kilograms by sizes, okay, the quantities, and we can also see here the plates that were used. For example, here the plates that were used to generate the connections, okay, with the size and the quantities and the material, everything is here. So it's quite nice to have an idea about the quantities and maybe then generate a bill of quantities of these materials, okay? So that was our section of steel structures. Let's go to reinforced concrete. But I will just leave this other structure calculating here in a background calculus. Let me open the shell's example because the results are quite nice. So let's leave it calculating. The analysis is going to be running here in a background. And let's go to reinforced concrete. So sorry, PowerPoint, no, just go to CYPECAD. So CYPECAD is our software to calculate reinforced concrete structures, or also metallic structures, also steel structures. You can connect CYPECAD with StruBIM Steel too. If you calculate a steel structure on CYPECAD, you can send to BIMserver.center and open here on StruBIM Steel too. It's the same process that we've made with StruBIM CYPE 3D. Okay, so both of them can connect with StruBIM Steel. And here we have some new features this year, and one of them is the possibility of import different type of columns that come from different IFC files. Okay, so as you know, maybe you know, when you introduce a column in an architectural model in IFC, these columns can be read by CYPECAD. Okay, so I'll show the difference that we have on this version. So I will just start importing a BIM model, and actually first I created this little example here on Revit. It's just some columns, some different columns. Okay, let me go here. So we have just some reinforced concrete with different sections and some steel columns here. I just exported to BIMserver.center using the plugin that we have on BIMserver.center. And now here on CYPECAD, I will select the same project that I created before, and I will import these columns. Could be a huge structure, but it's just an example to show the different situations that we can have with different columns. Okay, so I have created a project that was named 5 columns. Okay, very smart here. 5 columns project. Okay, let's load that. Okay, so here we have these 5 columns here. Okay, and here we have one level on the project. It doesn't matter to this example. And here we have these columns. Okay, so this is the menu that is new. So here we have actually new features. The menu, we have this menu in other versions, but here we have new features. And the main difference is, from now on, you can import not just reinforced concrete columns. You can import columns from every material. Okay, any material. Okay, so here we have some reinforced concrete columns and some steel columns. Okay, as you can see, by default, we cannot import these sections here that are those sections made by steel. Okay, why? Because first we must set one cross section that will be used to calculate this column on CYPECAD. Okay, because actually these columns that we imported were architectural columns and not structural columns. So we must create this correlation between architectural columns and structural columns, okay? So for concrete, it's quite easy, and the program do it automatically, because the rectangular columns are always just 2 dimensions and are made by concrete. So the software can create it automatically. But when we are talking about steel columns, we need to access a library of sections, and maybe we don't have this library, or it's not the same designation, the same name that we have in our IFC file that was important. So then we can click on these elements here, okay, and define and look for a equivalent column in our library. For example, here it's going to be a steel column, and I will select this file here. So if I come here, I can I can't find the W series here, but if we open our library here, we can assess this different predefined section series, and maybe we have a W series here. So we have here a W series here, W section. I will import that to my library of CYPECAD. I will accept, and now I have the W available here. Okay, so it was the W 250. Let's look for that. 250. It's going to be somewhere here. 250 by 73. So it's this one. Let's accept. And now we have the green check here. Okay. Something that we could do is, the architect introduced some columns, but it was just a generic column with all the dimensions were not okay. I think the dimensions must be different, or maybe other type of section, and we can associate a different section to one of these sections that were introduced on the IFC file. That's not a problem. You, as a structural engineer, will define which is the best structural solution to these columns. This is just a name, actually. Okay, so we'll change this profile to this profile, for example. Okay, it's just an example. The same thing you can do with the concrete sections. By default, it was a reinforced concrete with these dimensions, but maybe you can work with you want to work with a mixed section, a composite section, okay, or a circular composite section. No problem, you can do that at any moment. And here I must create a section. Let me see if we have something. I'll just change here, for example, to a steel section. Is just an example, and you can create this correlation and decide which is the best columns that you wanna import or automatically introduce to your CYPECAD project. Once we finish that, we just have to click on finish, and let's see what happens here on CYPECAD. Let's accept here the materials. No levels at this moment. So here we have our sections, and if we go to beam definition, and we can go here to the 3D view, the other button, we can see the sections here inside of CYPECAD. Okay, so that's one of the new features of 2021 version. So you can import different types of columns and create this correlation between architectural columns and structural columns. Okay. Another new feature that we have here on CYPECAD, let me open an example. It's the new soil structure interaction. Okay, interaction. Let me see here. Okay, let's open here. So this is a structure that a colleague was developing before. It's a 2 or 3 story building made. Oh, here we have some strange things here with these columns here, but no problem. It's a three-story building made with footings, foundation made by footings. Okay, So there's a little problem here. Let me see. Okay, I think it's okay. So here we are on the foundations, and the new feature is here on the foundation menu. After introducing the columns and the beams, we have this new option here. It's the soil structure interaction. Okay, so we can adopt this kind of introduce this kind of factor in our analysis and see what happened when the forces are transmitted from the foundation to the structure and the structure to the foundation. So we can just select if we want to consider or not the soil structure interactions. So if it's pink, it's not considered. If it's blue, it's considered. And if we decide to consider the soil structure interaction, if we are calculating with a footing, we must add a subgrade modulus, okay, the Winkler modulus, the subgrade modulus. And if we are working with pile caps, we must add the actual stiffness of one pile of our pile cap, okay? So we have both values that we can introduce here. And then we can assign, for example, to one element, okay, and say, I will consider that. First of all, I'll say that here, like in a pink color, it means that we will not consider that that interaction, okay. But if we change to blue color, we can say, okay, now I'm considering the interaction to this element here. Of course, we will do that for all the elements. No, we can do like this, for example. But the point is, the values of one subgrade modulus are different because it's a value that depends on the characteristics of the terrain, okay, the soil, and the size of the footings, okay. So maybe we will have to first create a first calculus with a number, a generic number here, a number that is something that could be the size of one of these footings. Generate first calculus, then see what is this results to the size of the footings, and then adjust just the numbers to each footing, adding a specific number that is according to the size and the size of the foundation and the characteristics of the soil. Okay, so we can do, it's why we have this option to assign to all, as we made before, or assign a different value to each one of the elements. Okay, once we calculate that, we have a nice report here. That is the second option. That is the characteristics that we have been considering for the soil in structure interaction. And if we open here, we can see the results, okay, so of each element. And after calculating one time, we have two columns like this. Now we have just one, but we can have two columns like this, comparing the first and the second calculus and highlighting the difference between them, okay. So it's quite nice. It's a quite interesting new module that we have on CYPECAD, okay. And a third new feature that we have on to reinforced concretes, it's something about the shear walls that we can introduce. Let me open a new example here. This model here, okay. This is a project. Let me open it. I think it's opening. Come on, what is happening? I think yeah, it has the wrong yeah, here it is. So here I have another beam model that was created using a lot of tools from BIMserver.center. Okay, let's take a look on that. Let's go. Let me see if we have any question here. Here we have this 3D model that was created using some tools from CYPE. And here, let me deactivate some layers. For example, the architectural layer. So here, let's deactivate the architecture. Then, for example, some pumping facilities that we have here, some carpentry, some stairs, some suspended ceilings, fire protection, HVAC, electrical mechanisms, furniture, and here, okay, I think it's okay. And this guy's here. As you can see here, this structure was made using CYPECAD. So we have here our beams, our columns, our slabs here. And then we have this rigid nucleus here, this wall that was calculated as a shear wall. What it means? Could be a high building, or maybe a seismic area where we could have horizontal forces actuating on this wall. So we must calculate that adopting a different procedure. Okay, so these calculations are made using a new software. Actually was launched on the 2020 version, so last year, and now we have new features on this application. Okay, we'll see the workflow here and use the workflow to show the new features that we have on these applications. Okay, so first we'll create our model here on CYPECAD. We'll introduce a wall using just the menu walls, define a wall, and when we create a wall, we have this option here. Let's check this option and say to the software that this is a shear wall. Okay, so if we do that, we must create a label and classify these shear walls. And if you see my shear walls here, that are both of them here, if we edit these shear walls, we can see that it was a shear wall. This is the size, and this is the label. Okay, and we can see here on the walls menu a 3D view of these shear walls. Okay, these are the shear walls. One label, it was one name, one label, so the yellow, and then the purple. Okay, for each label, it's gonna be a different color. Okay. With that, after calculating the structure here on CYPECAD, we export to BIMserver.center this structure, and then we can open on StruBIM Shear Walls. Okay, StruBIM Shear Walls, it's the software where we design these reinforced concrete shear walls. Okay, so I will just open here one project. Okay, and this software will read these walls from CYPECAD, and here we have tools to design these shear walls. Okay, so here we can see the type of walls that were imported from CYPECAD. Okay, here we have a lot of options to design these walls. We have here the check menus. We can verify as floor by floor each wall. Okay, and there is something very interesting, that there are the coupling beams. What it means: when we create a wall, especially when they are close in each wall. So if we have two walls, we have to create a beam that is a special beam to link one wall to another one. So that must be a very rigid beam. We must create a beam with a big section. Okay, and this beam have a different kind of reinforcement. Okay, so these beams are called coupling beams. And this is the new feature that we have on CYPE 2021. Okay, so here we can see some of these beams. Let's see that they are normally they have just some centimeters. They are just some centimeters long and almost the same size high. Okay, so they have a ratio longitude to height that is very low. Okay, and they have this kind of cross reinforced reinforcement. Okay, so these are the coupling beams, and from now on, from the 2021 version, we can also calculate this kind of beams, this kind of special beams. Okay, so we have here some tools to calculate that. Okay, we can design it. Let's see this example here on 3D using this 3D view here. And let's see, just to have an idea how it where these beams are located on the structure. Let's swipe. Here we are actually, we see a high level detail model with the reinforces, all the rebars that we have on our project. Okay. And someone just saying that it's not possible to hear, it's not audible. Please, could you confirm, someone, if the audio is okay, just to be sure. I have here one assistant that is saying that it's not possible to hear. Please, if you could confirm, please. Okay, we are generating this 3D model. Maybe let me see here if you have any answer. I can hear fine, sound is still fine, my audio is fine. Thank you very much, Fauch, Jeremy, Marlon. Thank you very much for your attention. I appreciate that. Okay, it's almost finishing. It's generating this new model, and we will see this coupling beams on the structure. It's quite nice because actually it was not calculated, so we just calculated that before generating the 3D view. So it's why it was need these 2 minutes of calculation. Let's open that. Let's see. Okay, come on. Let me see, I have a new question here. Let me see. Can we export? Yeah, I will talk about the exportation in a while. Okay. I think now you can, let me see. Okay, now you can see the 3D model, this 3D model that was created before. Here we have the structure made with CYPECAD. We can deactivate the structure made with CYPECAD. It was this structure here, and here we have the shear walls that were introduced and calculated here on StruBIM shear walls. Okay, these are the structures, the structure. Okay, and the coupling beams we use to connect two shear walls like this. So it could be here the connection between two coupling beams. Okay. Here actually we are, what we see here is a result of the calculus of these shear walls. Okay, actually not the rebars. I'm sorry, I was wrong. We must go to another software to see the rebars. We can see that. Okay, but the coupling beams are used to connect two shear walls like here or maybe here. Okay, almost always we do that above the doors, for example. It's a common place to add these coupling beams. Let's open with StruBIM rebar. So here, from here, we can export that to BIMserver.center and use StruBIM rebar to generate the rebars of these walls and coupling beams. So let's open it here. And here on StruBIM rebar, we have the rebar of we can generate the rebar of the wall. So as you can see on the base, we have much more bars than the top. Okay, And we have here the coupling beams. Here, these are the coupling beams. We have different types of coupling beams here, depending on the position and the forces. Okay, and we can see here on the 3D view now the rebar with everything. So here, this is the rebar. So it's something crazy because it's a lot of details here. So the beam model with the CYPECAD structure here, we can see the walls, the rigid nucleus here. Okay, and let's deactivate the CYPECAD structure. Here we have some let's do something like this. It's quite difficult to see because there is a lot of things here. Here we can see the rebar, the coupling beam, okay? Or here it's going to be better. Linking two different shear walls, okay? Different shear walls. Then here we have another one that is not so high. We can see that we don't have that cross section, okay? The different rebars that we have on the project, okay? That's quite nice. And of course, we can export this information to BIMserver.center. And then here back on CYPECAD, we can view this 3D rebar on the BIM model. And of course, if we created our architectural model using CYPE architecture, you can also view that information on CYPE architecture or any other software created by CYPE. Okay, so that's the workflow. That were the new features that I was wanting to show you today. Let me see. There were two questions here. Let me see that. Let me see. Tato is asking us if we can do the welding like Inventor. Tato, I'm sorry, I don't work with Inventor. I don't know exactly how the welding are made with Inventor, okay? But we have a lot of options to add weldings. I'm sorry about that because actually I don't know the program, okay? And Rakesh just asked us if CYPE 3D or StruBIM CYPE 3D does curved beams analysis. Yes, you can do a curved beam, but you must generate a combination of segments. So it's why using CYPE architecture using CYPE architecture could be easier to create these curved beams. So to do that, you can come here on CYPE architecture. Let's go there, CYPE architecture, and use these arc tools here. And you can set up the number of sides of this arc, the sides of the arc actually, because the arc is made by little lines. Okay, so you can create an arc with more or less lines, and these lines will be little bars of your model that you introduce to CYPE 3D and calculate the curved structure there. Okay, here I'll show an example of that if I have it here. This was the example that we made before. We will open that on a while. Let me see this guy here. It's a quite nice structure. Okay, that was calculated here on, and it's under calculation yet on CYPE 3D. That is a train station. As you can see, it was made with CYPE architecture. And here we have the architectural model and the structural model that was introduced here on CYPE 3D. And we can convert this concrete, reinforced concrete arcs in steel arcs, okay? So just creating little lines that combined generate this arc, okay? Let's see if we have more questions here. Can we export all structure back to Revit? Yes, we can export that, okay? Just, it's quite easy. You just have to export everything to BIMserver.center, okay? And once you have exported it to BIMserver.center, you just have to use this plugin here and do the same thing here. Consult the project status and download the IFC files to Revit again. Okay, here the example we were working before. I think I have it here. Let me see, where is that? I think this example is one of them. It's a structure that was calculated on CYPECAD, but could be CYPE 3D, okay, and was sent back to Revit using the add-in, this add-in here, okay. The add-in is for free. You can download this add-in, and you can download the add-in here from the store. It's gonna be maybe on the free tools, I think, or in the popular tools. Let's see. The free tools here. Actually, it's here. Plugin Open Beam for Revit. Okay, so on the popular tools you also have it. It's a free add-in that you can install on Revit to send and receive information to BIMserver.center and use it with CYPECAD or CYPE 3D. Okay. I think we don't have any other questions. I hope it was a good presentation. It was a pleasure to share these moments with you during this presentation. If you have any doubt, you can send emails to us using our contact forms on our website. Okay. And I hope it was a good presentation, and I hope we can meet in another presentation in the future. Okay, during the next days we will finish our CYPE 2021 release or launch with other presentations in Spanish and Portuguese. Okay, you have here the calendar, you can follow that. Okay, and I hope I see you soon in a next presentation. Thank you very much for your attention, and see you.